working backwards. I'm asking you to find f, so that's the antiderivative. Here's f prime, so this was the derivative. So we have to start out doing the antiderivative here. So f of x equals, what is the antiderivative of e to the x? Still e to the x. Actually, can we skip this one?
Yeah.
It involves inverse trig functions, and I never made you memorize those. We just did them from the book. So I'm not going to do that one. Can we start off skipping an example? That's a good start.
Or we can come back, we're just gonna skip it.
We're just going to skip it.
Skip
Alright,
it.
we're going to do this one. Okay, I gave you the second derivative, and I want f. So how many antiderivatives do we have to do? 2. Okay. So if I'm working backwards from the second derivative, that would take me to the first derivative, right? So 12x squared, what is the antiderivative of that?
36x cubed.
Well, you have the x cubed, the 12 stays, but then you have to multiply by the reciprocal.
Oh, yeah.
So that would give us 4x cubed. Okay, so 6x. So you add 1 to your power, so that's a square. So then you have to multiply by 1/2. So we get 3x squared. Minus 4, you have to add the x back to it. What else do we have?
C.
Let's see.
Okay. I need to figure out what c is. So, I'm going to use this. F of 0 equals 4 and f of 1 equals 1. Now, these are for the original function, right? Do we have the original function yet?
Nope.
Okay, so let's keep going. Let's do the antiderivative of this. So if you're at the first derivative, then we'll go back to f. What's the antiderivative of 4x cubed?
X4.
X to the 4. Antiderivative of x squared.
X cubed.
Antiderivative of 4x.
4. No, it's actually like
Antiderivative of c. And then we have a new constant. Now I don't want to put c because do these two constants have to be the same? So let's call it k. Alright, what I have given you here is the information to figure out what c and k are. So when I say f of 0 equals 4, that means if I plug in 0 for all of my x's, it equals 4. So if I put in 0 for all my x's, what do we have 0 plus 0 minus 0 plus 0 plus k equals 4. So I know my k value is 4. F of 1 equals 1. So 1 to the 4th is 1, 1 cubed is 1, 2 times 1 squared is 2, c times 1 is c, and we know k is 4, and that equals 1. So c plus 4 equals 1, so c is -3. So the original function, meeting all the specifications, the x to the 4th plus x cubed minus 2x squared minus 3x plus 4. So if you have any information, you can sometimes find those constants. Sometimes these are called initial value problems, if you have one of the values from the original function. So do you guys think you could do the antiderivative for this one and find the c? Are you ready to try one on your own, or should we do it together? Together? Okay.
I love our comments.
Alright, what's the antiderivative of x to the 4th?
1 and x5.
Minus, what is the antiderivative of 3x?
3 over 2.
3 over x cubed. That's like 3x to the negative 3 power. So if you add 1 to your power, that's negative 2.
So it's minus 3 over 2.
Let's see. How do we find c? Okay. So f of 1. So if I put in 1 for all my x's, we get 1/5 minus 3/2 minus 3/2 plus c. And that has to be negative 1. So we get negative 11/10. Is that right? No, that's not right. Okay, hold on. That's wrong.
I'm getting there.
Well, I'm not doing it. You guys are just back there.
Wait, no, that's actually not what I got. Wait.
Okay.
Negative 14 is plus c.
Right.
Oh, it
Okay,
is
so this
negative
is
14.
negative 3/2 minus 3/2 is negative 6 over 2, which is negative 3. So 3, that would be like 15/5. So 1 minus 15 is negative 14/5. So if we add that
That's what I
over,
got.
this is negative 5 over 5 plus 14 over 5 is 9 over 5. So the original function is 1/5 x to the 5th minus 3/2 x squared minus 3/2 x to the negative 2 plus 9x. All right. So far, so good? Let's talk about how this relates to a graph. So this is the graph of a function, and I want to graph the antiderivative. I'm telling you that on the antiderivative, f of 0 equals 2. So on my new function I'm drawing, f of 0 equals 2. That's the starting point. Okay. So now we have to think. What I'm looking at is essentially the derivative. Okay? If the derivative is negative, what does that tell you about the original function? It was decreasing. And then if the derivative is positive, the original was increasing. So I have to increase until I get to 3. And then after 3, my derivative was negative, so my graph was decreasing. It does kind of flatten out here, but it stays negative. So it's still decreasing, but very, very slowly, because that's a very small number, so it's kind of like a horizontal asymptote there. So I'm going to just decrease and slowly flatten out. Now, nothing precise about that graph at all, but we're just looking at increasing and decreasing. How does that relate to the original function? All right. Now let's talk about refresher. We know that position, velocity, acceleration are related. Okay, if x is my position function, how do I get velocity? How do we get acceleration?
Second.
Double derivative? That is more fun, isn't it?
Double D. I don't say that. That actually that's not right. Never mind.
Let's just go with
Let's just go with DD.
second derivative. Sounds better.
Double derivative? That sounds good.
Okay, let's look at this one. So I want the position function, and I gave you acceleration. So what do we have to do to acceleration? Yep. When you do the antiderivative the first time, what am I going to get?
Velocity.
Okay. So the antiderivative of 10 be 10t. Antiderivative of 30t plus c. Can I figure out what c is though?
Yeah.
Yeah, because I told you the velocity at time 0 equals -5. If you plug in 0, you get 0 minus 0 plus c equals -5. So my constant is -5 there. And then to get position, what's my antiderivative?
5t squared minus 5t
minus 5t
minus 5t plus c.
K, whatever you want to call it.
Uh,
Alright, and we know that if I plug in a 0, we get 5. So my position function is 5t squared minus 5t cubed minus 5t plus 5. Lots of 5s there. Why don't you guys read the next one and see if you can figure it out? So it starts at rest at the point x equals 10. So at time 0, this thing equals 10. It moves with an acceleration of 12t. We also know something else. If it starts from rest, what is the velocity at time 0?
0.
Okay, so we want position. So we have acceleration, so if I go backwards, velocity would be
60 squared.
okay, can I find C?
Yeah.
So my C is 0. So my velocity is 6t squared. And if I have velocity, I can get position. So the antiderivative of 6t squared
2t cubed plus c.
I'm going to call it K just because I already used C, but just a notation thing. And I know that at time 0, this equals 10. So my K value is 10. So position is 2t cubed plus 10. Alright. Any questions there? I think I'm probably just going to do one more for today. Yeah. So we have a particle moves in a straight line and has an acceleration a of t equals 6t plus 4. The initial velocity, so v of 0, is -6. Initial displacement, this one used s for the position function instead of x, but it's the same thing. We're trying to find the position function. So if we have acceleration, then moving backwards, so the velocity would be
3t plus 4t.
and we know the velocity at time 0 equals 6. So if you plug in a 0 for all of your t's, that's equals 6. So here's -6, thank you. So the actual velocity is 3t squared plus 4t minus 6. Alright, so then we need position. The antiderivative of velocity is position, so that would be and we can find k because we know s of 0, we plug in zeros for all of our t's, equals 9. So the k value is 9. Alright, are we okay with this? Then, yesterday you did 1 through 17 odd, right?
Yes.
So I want to finish it. We are not going to do problem 16.